Assalamu alaikum students. In this video, we are going to discuss about the energy resources. Actually, the topic is continuous. I have discussed that before that we have discussed about energy, the work done, then energy, then power, then efficiency and everything. Now we are switching to the energy resources. So when we talk about a resource, what does it mean by resource? Resource is uh, that stuff, that material which can be used for different purposes. Let's say it can be used for uh, working. We can use different resources for different purpose. So resource is your reservoir actually. So when you talk about energy resources, those all materials, stuff, phenomenons, processes in which energy can be utilized, that they are called your energy resources. So here the natural resources that can be converted by humans into other forms of energy in order for the useful work. But what are the natural resources actually? Natural resources are those substances or organisms in which we are getting energy from the living things, like your plants, animals, microbes, and everything. We get energy from those all. So that is called basically the natural resources, because you are aware of this term, you are aware of this technology, that we are having fossil fuel as a biggest source of energy on the earth. That all is coming from natural resources. So remember one thing: sun is the most important energy resource for us, because I will enlist different energy resources. I will classify energy resources as well. But remember one thing, that sun is the most important energy resource for humans on the earth. Only, only geothermal energy and nuclear energy in the nuclear power plants, that is independent of the sun. Just remember one sentence here, that this is a question asked to you in your past paper, that what are the energy forms, or what are the source of energy or energy resources which do not use sun. So here is one: geothermal energy, geothermal, and nuclear. I will talk about these in detail. Okay, so here we go. There are different types of energy resources. There are two main classifications actually. One classification is your renewable energy resources. Renewable energy resources are those resources which are used but they are not consumed. They are used once, when they are used, they provide you the energy, but they are not consumed. They are just reused. For example, you can simply define the renewable energy resources that they can be used and replaced over the relatively short time. Right? Water, you can replace it. I mean, you can use it, not consume it. Use and consume, they are different things. Water is not consumed in hydropower plants. Wind is not consumed in wind energy turbines. Then solar energy is not consumed. They all are used. Okay, so these are some energy resources which are renewable energy resources. Here one of them is wind energy, the second one is the solar energy, third one is the hydroelectric power plants. Okay, then you have uh, wood and biomass, although it is consumable, but uh, we can put that in consumable, so just cross it, don't put it in the energy resources, I mean renewable energy resources. So these all are actually used to produce the tides. So this is what they all. Then we will talk about some other energy resources. I have enlisted all of them. That renewable energy resources are solar at the top, hydroelectric power, water wala, wind energy, which is using wind energy, I mean wind or air energy or wind energy, you can say. Then tidal energy, then geothermal energy, then biomass. These are six main renewable energy resources. Just keep these 6 points in your mind. And what are renewable? Solar, hydro, wind, tidal, and geothermal and biomass. So these all are your renewable energy resources. In all of them, I will explain one by one. But here I had to discuss about biomass, which was basically something new for all of you. That's why on the, you know, biomass, by its name, it is very clear that it is the mass or wastage of some living beings, just like crops, animals, right? The decomposed forests, decomposed crops, and the wastage of animals, right? Some fossils and everything. That all is used as a biomass. So, organic matter that contains stored energy or energy produced by heat within crust or earth's crust. For example, woods and plants are basically, as I have mentioned, that they are used as a wastage. So actually, what do? We put some wastage together in closed container, in which we put some bacteria inside, and we perform some decomposition process here inside this container. And when that decomposition takes place, or when the decomposition happens, actually some gas is being generated in this container, and that gas is being, or that gas is something like natural gas, and that gas is basically delivered with the help of pipelines from source to the consumer. So that is your biomass. So that is why I have just put it at the top. Then we have the other, geothermal energy. Geothermal energy is one of the most, available resource, but it is not easy to use. Why? Because we have to dig the earth deep into, and while earth is uh, just drilled into, what happens, this is that area where earth has the earth's crust is there, sorry, earth core is there. So there is magma and different materials which are very hot. So when we just drill the water, drill the earth, and we reach to that area, there are geysers of hot water. So those geysers come out, and we can use them. If we are able to control the geysers, we can find, we can use the energy of our earth's inner, as a useful form. So here it is, the harness heat from the earth's groundwater has seeped into the hot spot near the surface. I will show you this diagram, and that will make you very clear what happens where the hot spots are there. Earth, for example, volcanic areas are hilly areas where volcanoes are erupted, or it is the chance for the volcanic eruption. There, what do? Where we pump in the cold water, injection well. Injection well is basically that area where you pump in the cold water. Where you pump in the cold water, that water becomes hot near the rocky, or this is basically the channel where hot water, I mean, the earth is very hot inside, right? Rock layers, we just bore the earth, and we pump in the cold water. And then what happens? Then the water gets heated up, and it is basically lifted upward due to convection current, or we can pump it out. Here hot water is coming out of the earth. Now that hot water is basically distributed here. This is a distribution point. This one is what? That is your distribution point. So here hot water and cold water are separated, as well as hot water is distributed to the um, to the boiler or turbine. Here is basically the boiler or the turbine. So when that water is hot enough, it is converted into steam. So when it is converted into steam, that water is used to run the turbines. Here all that is used to run the turbines. And when it is used to run the turbine blades, those turbine blades are just connected to the generator. Electric energy is being produced here, and then electrical energy, yeah, electrical generator, or you can say electric energy is being produced here, electrical energy. And that energy is being used, or that is being delivered to the homes and other areas with the help of these poles and these high transmission voltage lines, right? So I believe that it would be very clear. That is the entire block diagram, or the working diagram, real-time diagram of your geothermal power plants. Now, here is the block diagram that what is the flow of energy. So geothermal energy is being delivered to the boilers. Boilers produce steam, and that steam is used to run the turbine. Turbines are used to run the generator, and then generators are used to produce electricity. So I believe that it would be clear to you. So this was basically related to your geothermal energy. Then the next energy resource, which is very common in our daily life, that is our hydroelectric power plant. In hydroelectric power plant, we use water to run the turbine. Check this one out. This is the model diagram in which I just shown you that there is a turbine probes, and when water falls on those turbine, what happens? It rotates. When it rotates, its rotation is just transferred with the help of a shaft to the turbine, and then with the help of a conveyor belt, we have connected turbine with a generator, electrical generator, and then electrical generator is producing the electricity. This is very low level. I mean, this is the model, right? But at the higher level or at the commercial level, we use dams. Dams are reservoirs of water, and those dams are having water channelized. So when the water is channelized, that water produces kinetic energy. It has kinetic energy, and that kinetic energy is used to run the turbine here. And then water is not consumed. Just see that it is just it went to the lower reservoir of the water, and then when it is used to run the turbine, turbines are connected to the generator. This is the powerhouse actually, and then the power electricity is being produced and delivered to the consumer with the help of these high transmission voltage wires. This is again the second important transmission line, sorry, power plant. Now here, that is potential energy. This is the flow chart, flow diagram of the EPA, electrical powerhouse or electrical power plant or electrical power energy house. So potential energy of the water at the higher level is being reserved, stored, and that is converted to the kinetic energy of the water. When it moves through the pipe or the channel, its energy is converted kinetic energy, and then that kinetic energy is converted to the mechanical energy of the turbine. Turbine runs, and it provides you the mechanical energy, and that turbine is connected to the generator, and then electrical energy is being produced, and that electrical energy basically alternator or you can say generator. So that is used to produce electricity, and then we provide all that electricity to the consumer. So this is actually hydropower plant, and that will be asked to you in this way. You can ask about the turbines working. This is the third one, that is actually the tidal energy. Tidal energies are those energies which are independent of sun, but we consider that the tidal energy is used to produce with the help of moon's gravity. So remember one thing, the tides are very powerful source of energy in the oceans, and when there are oceans, there are low tides and high tides. Low tides, during low tide, water is just decreased down, water level is decreased down, and during high tides, water level is increased. During this high and low moment, we just run this turbine, right? When the energy or the water is converting from low to high, it is filling up the dam or the dike, and then during that the turbine is being run, and that turbine is connected to the electricity, sorry, to the generator, and that produces electricity and so on. So tidal energy is source of renewable energy which is used to generate electricity. Tides are caused by the combined effect of moon and earth's gravity and sun's rotation, but sorry, rotation of the earth and the gravity of the moon. So remember one thing, that tidal energy is that energy which is its main reason is moon. The tides are produced with the help of moon. So that takes place on the coastal area. That's why all these tidal energy plants or power plants are on the seasides, are in the sea, and at least 5 meter height should be there for high water and low water. That can be produced, or that can be high electricity, or you can produce electricity for if 5 meter high tide is being produced. Then we have solar energy. Solar energy is, as I told you, the biggest source of energy is your solar energy. That energy is coming from the sun. It is coming in two different ways. One is when we are directly using it as a sunlight, and secondly we are using it with the help of solar cells. Okay, so when we are using it in the solar cells, you can simply say that large solar panels are made by using small solar cells, and then they are used directly to produce electricity, or they are used with batteries to produce electricity. So energy from the sun on the earth is transferred in the form of radiations, in the form of radiation, that energy coming from radiations. Then these radiations are in the form of light and infrared radiation and all that stuff. So when you are having this concept in your mind, that we have, or we receive the solar energy as all seven spectrums of light: gamma rays, ultraviolet, x-rays, visible light, infrared, microwave, and radio wave. So all they are coming from sun to the earth, and we are using them. We, with the help of a collectors, very large devices, just like dish antennas type devices, are used to collect the energy, right? And although collecting mechanism is expensive, but it is one-time investment. For example, most of you are familiar with the solar. We have a lot of investment on the solar, but once it is invested, you people get, you people get rid of the daily or monthly electrical energy bills. So that is one of the important thing what I wanted to share with you. Secondly, that solar energy is being transferred with the help of solar cells in our daily life, in satellites, in our daily life, electrical, solar power stations, solar panels, we use all of that. So energy is generated that can be stored in the batteries for later use. For example, in the night time, you can use the energy by batteries, because in night time solar will not work. Okay, and here is an example of that. I have just selected this diagram for you people. This is the solar panel, small solar panel, solar collector, that is also named as solar collector. And we have just millions of solar panels, solar cells connected in solar arrays like this. All I have just selected this diagram for you people, that you can see that they have put all the solar cells in a proper array, in the formation that they will be exposed to the sunlight. And when they are exposed to the sunlight, actually they can give you the solar energy. They have the radiations from the sun, and those radiations are being absorbed by them, and then they convert these all radiations into electricity, and that electrical energy is used for different purposes. Then these are the solar mirrors. Solar mirrors are basically those which are having black color. They absorb all of the radiations are there, and they trap the radiations, because they are having they are having glass surface. So when they trap the radiations, this is the internal structure. Here, thus they trap the radiations. It causes heating, and the water which is coming the from the reservoir, cold water is coming, or that is pumped into, or you can say that is delivered to this, and through this copper ducting. Actually, this all is the duct. So copper duct is used. That copper is very good conductor of the water. So here, cold water is getting in, and water is circulated in this all. And when it is circulated, it comes as a hot water, and then hot water is distributed, right, to the same tank. And then that tank is basically using water as a hot water. So that is a hot water geyser. So it is normally called solar geyser. We call it solar geyser. Then the tidal energy, sorry, this wind energy. Wind turbines are used to produce electricity while rotating. On coastal areas, we have very strong wind, and we have a array of a series of windmills. They are windmills. These all are generators. Their efficiency is very small. They are producing very low energy. That's why we need a lot of windmills together to produce, or to basically overcome the energy crisis, or to overcome the energy requirements. So that is basically all about the renewable resources. So then you have then you have some advantages and disadvantages there. So advantages and disadvantages mean solar. There are some advantages. This is this column, left column is for advantages. The right column is for disadvantages. I believe it is not that much hard enough. Okay. So solar energy is almost unlimited, right? But it is expensive to use solar energy for different situations. Okay. So what about the water? Water is a renewable source of energy and it does not produces air pollution. Similarly, solar does not produces air pollution, but flooding and just the disturbance of the ecosystem is one of the disadvantage of your water reservoirs. Then um, wind wind energy has relatively inefficiency. Inefficiency means we have to use a lot of windmills. That is its disadvantage. Otherwise, it is pollution free and it, wind is available freely. No no expense at all to purchase the energy, but there is an expense to install the windmills. So that is one of the disadvantage. Then geothermal energy, it is all again limitless energy source, and power plants are required a little, and a little land is required. And then its disadvantage is only that you must have a proper location for these geothermal power plants, because they will not work all around wherever you want. You have to go to those areas where a volcanic eruption is expected, but that is another danger for that, dangerous effect of that. Then biomass, it is renewable, but it requires large areas and farms to produce smoke. That's why this is its disadvantage. It has some sort of your pollution is one of them, one of the disadvantage. Then in next lecture, inshallah, I will talk about the non-renewable resources of energy, because it is a long topic. So I have split it into further subdivisions. I hope that this will be very clear to you. And if there are some questions, you will ask me. Thank you. Allah Hafiz.